Hey everyone. So much people, yeah. And I have an honor to open this meetup. And I'm happy to open it with a controversial topic. Um, yeah, so in short, yeah, I'm Nikita Zavadin. I'm software engineer in Wolt Drive team, and also I'm competence lead of Python in Wolt. Uh, just I will tell a little bit about what we do in Wolt Drive. So we give our API and our platform and our logistics to merchants who don't want to be inside of our application, and so they can use our API to deliver almost everything. So they can integrate with our API and get all the benefits of Wolt. So like quick deliveries and trackings and all this stuff. It all started as a microservice, but yeah, now it's not microservice. And that's how this topic was born, because yeah, our service became too big, and we had to find some way to work with our dependencies. So yeah, and let's start. So let's start from some basics, like what is dependency injection in a nutshell. But I won't dive very deep into it. So, but in short, yeah, just design pattern where that says that dependencies should be passed from upper level, so it should be passed to class rather than class creating its own dependencies internally. Uh, when you write like small projects, yeah, that's okay, to live without dependency injection. But when you write enterprise code that grows a lot, you need to find a way how you can structure your code to make it more modular. So when team grows, they can develop their parts independently without huge merge conflicts. And it should be, of course, maintainable. So you always know where you should put your logic. And of course, test is also very important, because yeah, if integration tests are great, they're important, but they can show you that you only have a problem, but they don't show you where exactly you have a problem. So you have to structure your code, modular, to test every dependency independently. So you can find exact place where you have a problem. So yeah, here you can take a look at very a simple dependency graph. So we have delivery order service that has as dependencies delivery fee service and payments client, and delivery fee service also has as dependency repository, and repository also has as dependency database. So yeah, it's like a layered architecture, and you pass everything from the above. But yeah, how you can work with dependency injection without dependency injector? Yeah, the most obvious way, yeah, it's manual dependency injection. So yeah, you just have one huge function that constructs your application, but of course, obviously, it has some problems. So first of all, yeah, you should, as engineer, always remember to call startup and shutdown methods manually. But of course, yeah, we just people, we can forget, but it can lead to incidents in production in worst case. Yeah, so yeah, this like reasonable thing. And yeah, eventually MainPy ends up being just a very huge file, maybe not with thousands, but with hundreds of lines of code. So yeah, in our case, yeah, it became a big problem. So it was hard to add some new dependency, and it even worse if you have multiple entry points for your application. For example, you can have service and workers, cron jobs, and yeah, and to keep this huge main file in multiple different places, it's challenging. And yeah, problems. There are a lot of problems with testing. Yeah, it's very hard to override only one dependency. You need to use some monkey patch, and monkey patch it always work in a very weird way, and usually it also shows that you probably have some problems with design. So let's think how we can work in a different way. We can use global variables, but still, like it doesn't solve problems. Actually, it only creates new problems. But yeah, it's a little bit easier to to write. Still, yeah, you have to remember to call startup and shutdown methods. It's still hard to override dependencies, so your testing experience will be horrible. And what it makes even worse, it's import side effects. So it means when you import just simply import module, some of your dependencies can do some IO task, for example. For example, database can try to open connection to database. And it's a problem because when you write your code, you should expect that import do nothing except import. And yeah, you can face this problem in unit test when you just import function to test. But yeah, it fails to connect to database. And you need to first configure your whole environment just to run one unit test. But yeah, we face like with two concurrency issues, like in real world, not problems that came from my head. So first of all, yeah, process in Celery forks main process, and it can break some clients. For example, Kafka. We had like Confluent Kafka, as I remember, and after all workers started, yeah, it broke some connections in Kafka. And the worst part, that these connections are breaking silently. So we didn't know that something is broken until yeah, we saw that something is wrong with our metrics. And another problem, yeah, that wrong event loop can be attached. For example, this can happen with gRPC. For example, gRPC stops by default. They try to get existing running loop, and if there is no running loop, they create a new event loop. And that's how wrong event loop can be attached. So if you create a gRPC stub as global variable, it simply won't work. You need to create instance of your gRPC client only inside of running loop. So yeah, global variables simply don't work in some cases. But why dependency injector even matters? Here is a dependency graph of our service. Yeah, it was generated with MagicDI, and it's still not perfect. It should be even bigger because here you can find some dependencies that looks like Uber dependencies. They have too much responsibility, and we are trying to decompose them and split them as much as possible. So it will be even bigger. But even like right now, we had to find a way to work with our dependencies. And yeah, last time there were over 500 lines of code in MainPy, and it was impossible to take a look at whole file. Yeah, you have to turn your monitor somehow to take a look at whole MainPy. And of course, yeah, there was no way to split it into different files because it just was it was only factories. It was impossible to split it. But before developing something new, let's take a look at tools that we have already. So first, the most obvious thing, yeah, it's dependency injection in FastAPI. Yeah, because we use FastAPI for our backend. But what problems do we have here? Yeah, first, of course, yeah, you need to write endless number of factories. Like here, get database, get repository, get service. And yeah, they are different actually. It's not just the functions. Sometimes it's generator, sometimes in function. It can confuse. Because why it can confuse? Yeah, FastAPI takes care of it, but usually your application is not only limited to FastAPI. Sometimes, yeah, as I said, you can have workers, and you need somehow to use dependencies in your workers and cron jobs as well. If you wrote all these factories, probably you need somehow find a way to work with them without FastAPI. Probably there are some libraries, but still it seems weird because you lend your whole code base just to FastAPI. And here, yeah, connect and disconnect is called for every request. You still need to some workaround to perform these actions only once. So probably, yeah, you will store it in some global variable. Yeah, and of course, yeah, it's probably the most problematic part is that it's not possible to validate that your dependencies are properly injected on application startup. It happens simply because FastAPI doesn't know how, and there's no way. And we also faced with this problem when we found that our dependency is broken only after application deployment. So our deployment was successful, but when we received first request to our endpoint, we, because of misconfiguration, responded with 500. And it's very critical when one of your endpoints is totally unavailable. So yeah, we had to find a way how to validate that everything is properly injected, and to make, even if something is broken, we want to break on application startup, so deployment will fail. So yeah, let's then take a look at other existing dependency injectors. For example, Python dependency injector, probably it's the most popular. Let's take it as a reference. Problem of most DI libraries is that they are designed to be like general solution for everyone. And of course, it leads to redundant code. You have to write these containers. You have to register your clients, and yeah, you still need to properly always configure your clients, and it can lead to inconsistency because you can have different containers, and these containers can be different. For example, here service can be just a dependency that use factory, but repository uses singleton. Why not to make everything singleton? Why do you need to store all this context in your head? And still, yeah, you have to remember to call startup and shutdown methods manually. And of course, here we also can forget it. But let's dream a little bit. What if our injector was so that simple that you don't even need to configure it? So our application would look like this. So yeah, we just say, hey, this is my endpoint, and I need this service. So please inject it and resolve all dependencies. And that's all what you need to do. Looks very simple. And actually, yeah, that's what we developed in Wolt. But before that, I want to give some short disclaimer, because it's totally different what we have with dependency injectors. So when you will be looking at Magic DI, imagine that you're writing a new service, because yeah, you can if you will try to imagine how you refactor your old services, it can scare you, because of course there will be a lot of work to refactor your old stuff. But yeah, I strongly believe that it can be a game changer. So please try to imagine that you write something new using Magic DI. So let's first talk about core concepts of Magic DI. First of all, it's zero config. And it says that you don't need any kind of config to use dependency injector to make it work with your application. So nothing. You don't need to register anything. You don't need to write dependency containers. You just write your code, and that's all. And it also relates to your dependencies. Your dependencies should also be should follow zero config principle. It's not exactly like this, but it says that yeah, all parameters should be either injected or fetched from the environment, file, or any other source. So you don't need to pass anything manually. So yeah, here you can see that we have database. It has config, and this config also injectable. So dependency injector will inject config that, and config will fetch all required settings from the environment. And you can see also that it opens connections to database inside of connect method and close it on disconnect. It doesn't break solid principle because it seems fair that dependency knows how to prepare itself and finalize itself. So yeah, it opens connections and close. But yeah, if you will take a look, you can raise the question, how does dependency injector know what to inject? So let's take a look at this example. So yeah, we have a service that has as dependency repository, payments client, and just parameters like order counter and some feature flag. Repository should be injected, payments client should be, but order counter and feature flag has generic types like int and bool. So what should dependency injector do in this case? It simply checks every dependency if dependency implements connectable interface. So yeah, it has just this interface has two methods, connect and disconnect. And if your dependency implements this interface, it will try to inject your dependency into another dependency. Yeah, and the most interesting part that it uses duck typing to check that your class implements interface. So you don't need to inherit from connectable base class. Why it's important? Because when you write your code will not depend on MagicDI at all. So you just write your code, your dependencies, and that's all. You just have connect and disconnect methods that you can call manually if you will decide not to use MagicDI. Yeah, and here's an example that yeah, we have database. It explicitly implements connect and disconnect method, and service it just inherit from connectable base class. Both of these dependencies are injectable, and dependency injector will inject them. But class something do not implement anything, so it won't be injected. Yeah. But still, you can force dependency injector to inject something using annotated type hints. So here you can see that yeah, we explicitly say that hey, we need this dependency be injected in our service. So and that's all. So philosophy of MagicDI, you just write your code, and MagicDI will take care of everything else. You don't need to care about infrastructure stuff, so just write your business logic, and that's all. MagicDI will connect and disconnect our clients automatically on application startup and shutdown. And this idea was born during our hackathon, because we had very ambitious goal, but not enough time. So I had to find a way how we can speed up our development. And that's when I wrote a small prototype. Yeah, it went very well. And that's why we decided to develop it further. And yeah, it works perfectly because yeah, you really enjoying writing your new features. Let's continue with another core concepts. Yeah, also MagicDI guarantees proper order of injections. It guarantees that every dependency is ready to use once it's injected and connected. So let's take a dependency graph from the beginning and try to understand what MagicDI will try to do. First, it will inject database and will connect it. Then it will connect repository, after delivery fee service, payments client, and eventually delivery order service. So every dependency can be ready that its dependencies is ready to use. So here, yeah, you can be sure that database is connected. If it's not, you can raise exception. So if something fails to connect, yeah, exception will be raised by MagicDI, so you will know that something is wrong. Your application won't even start. And if something fails to disconnect, MagicDI will ignore this problem, exception, and will just log it. And will try to disconnect, other dependencies. But is it even easier to integrate MagicDI? Actually, yes. It's very simple. This is how your code will look like if you write FastAPI backend. Yeah, you just inject your application, and then when you write your endpoints, you say like, hey, I need this dependency, and it will be injected and connected automatically by MagicDI. You don't need to do anything else. So that's all. And unlike FastAPI's DI, yeah, MagicDI guarantees that everything is properly injected and connected. Otherwise, application won't even start. We also have built-in support for salary. Here you just need to pass our custom loader and custom task class, and then that's all. You only need to pass default value for your dependencies just to follow salary strict types. But if you will disable strict typing, you don't even need to use this provide in salary. But of course, it's not limited just to salary and FastAPI. You can use it with your custom code. So you can use inject and run util from MagicDI. And underneath, it will inject your function or class, will connect all dependencies, and will run your function or class if it has call method. So yeah, and actually underneath it just does this thing. So you can do everything manually. So yeah, it just creates injector, inject your function, connects everything, and calls your function. And after this, we'll disconnect your dependencies. So underneath, it just looks like this. And yeah, as I said, yeah, it helps with testing seriously, because usually you want to test that your main py also works. It also has no problems. But without dependency injection, you have to patch something, and patch is not the most reliable way. But here you can with MagicDI you can override any dependency, no matter how complex your app is, no matter how deep this dependency is. Just say like, yeah, I need to override this dependency to this mock, and it will be and mock will be injected where we use your overridden dependency. But of course, yeah, nothing is perfect. Of course, MagicDI has some cons, but yeah, first let's repeat all pros that MagicDI brings. First of all, yeah, engineers only have to write business logic. They do not need to spend time on boilerplate code, and it actually saves a lot of time, because your brain only thinks about your idea, and you just write code, and it magically works. But there is nothing very complicated, actually. So it's still easy to use. yeah, it guarantees that all your dependencies are properly injected, started, and finished. You don't need to care about this. Magic DI will take care of it. And apps that use Magic DI are easy to test, much easier, because it just forces you to write this layered architecture. So uh, you can unit test everything easily, and you can write integration test with uh, mocking only dependencies that you need to mock. And cons of it, yeah, it's very implicit. Yes, it can be a problem. It can be hard to understand for beginners. But you need just to spend some, I don't know, maybe 10, 15 minutes to understand how it works, because underneath there's nothing very complicated. It just parses type hints and recursively injects everything. So there is actually nothing very complicated. It just requires some time to understand how it works. It can be harder to debug because, yeah, it's just magic. But actually, it can, from experience, I can say that it's the problem when you refactor something. When you refactor your old code and when you migrate to Magic DI. But after you migrate it and you write something new, it's not actually a problem, because it just uses class signature, and these signatures does not came from nowhere. It came like from you, and you know what exactly to do. So like it's not in production, in a real experience, it's not a problem. And yeah, another con is that Magic DI is still fresh new library, so it might be not perfect yet, but nothing is perfect from the beginning. It still needs some time. And what next steps we can expect is that, yeah, we need you as community, and we need your help, because, yeah, it's production ready, but still it's not yet perfect. So that's why it needs community feedback and help in development. It can be, of course, scary to use because it brings completely something new, and there is a learning curve that to be expected. And it can be hard at first to understand how it works. But it can be a game changer because, yeah, when you write something new using Magic DI, you starting to notice how easy it to do something new. You can even when you change your code very frequently, it makes your experience much smoother. You don't need to care about all these configurations. You just write your code. So yeah, we would really appreciate if you would even just try to use it in your new projects, pet projects. So, and share your feedback with us. It would be really great. So yeah, if you have any questions, or you want to read more about Magic DI, so yeah, here are the links. So yeah, left QR code is linked to our GitHub repo, and the right one, yeah, it's linked to my contacts. So yeah, if you have any questions, please message me. I will be very happy to help you to understand how it works and how you can adopt it with your projects. So yeah, if you have any questions, please message me. Yeah, there you can find links to my my Telegram, to my LinkedIn, and of course my email. So yeah, that's it. So yeah, thank you for your attention.